An airplane travels 120 miles in 2 hours with the wind. The return trip against the wind takes 3 hours. What is the wind speed and the speed of the airplane in still air? So when you first look at this, it might just look like gibberish. I know this one can be a little bit intimidating. One thing we do know is we're dealing with distance, with time, and with speed or rate. And so that gives us a hint that we're going to be using this distance equals rate times time formula. Okay, when you're doing this kind of problem, the way I think is best is to use a table. And so we're going to have a trip there and a return trip. So that tells us we're going to have two different trips. We'll have a distance for each trip, a rate for each trip, and a time for each trip. So we know an airplane travels 120 miles and then a return trip. So right there, that gives us the distance. So it's 120 both ways because they're just going there and back. So there you go. We've got our distance filled in. Now 2 hours is how long it takes when it goes with the wind. So when it's going with the wind, you think the wind is blowing at your back, it's making you quicker. And so whatever the rate of the plane is, it's going to be added to the wind speed. So it's going to make us go faster. Now it makes sense that where the return trip against the wind, it would have to take longer because if you think like running into the wind, it's slowing you down. So that's going to be the rate of the plane, but it's going to have to minus that wind speed because that wind is going to slow it down. Okay, so we've got our table set up. Now we need to bring it outside of the table so that we can solve it. So what I like to do, since rate is the one with the missing variables, I like to rewrite my distance equals rate times time equation. And I'm going to solve it just for the rate so that I have it isolated. So I can see rate then equals distance over time. And so I'm going to use that from this table. So I have r plus w, which is my rate, equals the distance, which is 120, over the time, which is 2. So I rewrite this little equation, and I use that same idea to rewrite the equation from the table. And then we'll do the same thing with the return trip. We have now r minus w equals distance, which is 120, divided by time, which in this case is 3. Okay, so we've got our two equations. Let's see if we can simplify those. So that's going to become r plus w equals 120 divided by 2 is just going to be 60. And then we have r minus w equals 120 divided by 3, which is going to give us 40. And so this might look familiar, kind of what we've been doing this whole chapter. We've got another system of equations. This one is really nice because if you notice, we've got our wind, one's plus, one is minus, and so we can just add those two equations together without doing anything more. So the wind cancels each other out, plus w minus w. We get r plus r is 2r equals 60 plus 40 or 100. We'll divide by 2 on each side, and so we can see that the rate of the plane is going to be 50 miles per hour. Okay, now we need to figure out the wind speed. So we figured out above the r plus w equals 60. And so if the rate is 50, we can put 50 in for r, plus w equals 60, and then just solve for w minus the 50 on each side. And so we get w equals 10. And so here we'd have wind speed is then 10 miles per hour. Now on this problem, you may want to look and make sure it makes sense. So if you got wind speed was like 200 miles per hour and the rate was 10 miles per hour, you might think, maybe I switched the rate of the airplane or the speed of the airplane and the wind speed. So just kind of do a double check, and then you can also check and make sure they make sense with the problem. I hope that helps. If you're still feeling confused on these types, reach out.